Hey, it's Mr. Shrum, and I'm just going to go through these lesson activities. I think they are holding up a lot of people, and I think we will just go through them together, and I will kind of guide you through part A, part B, and so on after we briefly look over this article. And here we're just exploring the meaning of bias, how it can impact the scientific method, and then we're going to answer those questions. So, right off the bat, we have the title Views on Bias Can Be Biased. Men and women have different takes on studies of gender bias. So, let's read a little further. The scientific method is supposed to be objective. A scientist comes up with a hypothesis, a educated guess or prediction of an explanation. It's trying to explain what you see, how you experience reality as it is, and for how they think something works. Rigorous testing takes place. The scientist looks at the resulting data objectively and determines whether the original idea was right or wrong. There's no arguing with numbers. When in doubt, test it again. As my graduate advisor always said, the data are the data. But that doesn't mean that science is bias-free. After all, science is an endeavor performed by scientists. Scientists are human. They are people who come with their own beliefs and biases that influence how they see the world. A new study of gender bias in academic research puts the lens not on that bias, but instead on the interpretation of studies of it. So these studies are studying bias, and then they're looking at how that bias manifests itself. How does it show? And the results show another level of bias. Male scientists view studies of gender bias in academic research less favorably than do female scientists or male researchers in other fields. But the good news is that combating these preconceived notions about gender bias research can turn faculty hiring toward equality. When Jesse Smith, a social psychologist at Montana State University in Bozeman, received a grant from the National Science Foundation to increase the participation of women in science, she started meeting with faculty to tell them about gender bias in academic research. As part of the meeting, she handed out copies of a study by Corin Moss-Rakusin and colleagues at Princeton University in New Jersey, published in 2012 in the Proceedings of the National Academy of Sciences. The study found that male and female science faculty ranked job applicants as more hireable if their applications featured male names. This is a subtle gender bias in favor of men. Their article showed men and women hold these biases to the same degree. No blaming here, not just one gender at fault, Smith says. But she soon realized that not everyone saw the study the same way. Many of the men she passed the paper to started picking apart the study design and the flaws they saw with the paper. Smith often ended up trying to convince the scientists that there were many other papers out there showing gender bias in science. I was very surprised, she recalls. I thought it was going to seal the deal. You can't argue with data. But it turned out that many scientists could and did argue with the data. And I think a nice parallel here is to see that some medical professionals, some scientists, are misusing the COVID data, mask data, and I'll let you do your own investigation into that. Ian Handley, moving on with the article, Ian Handley, a social psychologist also at Montana State, overheard Smith discussing the issue in the department hallway. I was really interested, he says. As he and Smith discussed her observations, they wondered if, when it comes to studies of gender bias, people just don't want to hear it. They decided to conduct a survey to find out whether scientists really do approach research about gender bias with some preconceived notions. Preconceived meaning you thought of them before, you've conceived of them before. Using Amazon's Mechanical Turk, which is, if you guys aren't familiar with that, I'll show you. It's how Amazon gets people to do work for them without, adequate pay. But that's a whole other thing. Let's not get into that. So anyway, they use that to recruit 205 people, 146 men, 59 women. And the participants were asked to read the Moss Rakusin abstract. The abstract is the little introduction to a scientific study article, and rank how favorably they viewed the study. So they recruited these people, let them read the introduction to the study, and then they ranked how favorably they viewed the study. Okay. So these questions that they asked them included how well participants felt the abstract was written, if they thought the research was important, and if they agree with the results. So you can see how, they're not really asking super scientific questions. These are a little more subjective. So how well did they feel the abstract was written? Did they think it was important to research? Did they agree? So both men and women viewed the abstract relatively favorably. Men ranked it significantly less favorably than women. Those people were not scientists, so the researchers also surveyed 205 academics. So these 205 people were people not steeped in academics or studies. So they got another group, and they were specifically in science, technology, engineering, and math fields, as well as some non-STEM fields from Montana State. They presented participants with the same abstract and questions. Again, while both genders ranked the abstract generally positively, men ranked the abstract less favorably, agreeing with the results less, ranking the study as less important and less well written than women did. When the faculty were divided into STEM and non-STEM disciplines, non-STEM faculty showed no gender differences in their rankings. Only in STEM fields did the male faculty rank the abstract less favorably. So in a final test, the researchers went back and recruited another 303 people. These people received a second abstract by Sylvia Knobloch Westerwick and colleagues at Ohio State University in Columbus, Ohio. This paper published in Science Communication in 2013, so this is about a year later than the one they published earlier. But this paper showed that the people rank science conference abstracts more favorably if they are associated with male authors. So this time, the researchers presented either the original abstract or an abstract that altered the findings to show no gender bias in conference abstract ranking. Men once again gave the abstract showing gender bias less positive rankings than women did. But when the paper was altered to show no bias, male views changed, and they liked the abstract more than the real bias demonstrating results. Smith and colleagues report their findings October 12th in Proceedings of National Academy of Sciences. So, why does the bias exist? Hanley notes the effect could be a matter of confirmation bias, Women already believe there's bias, he says. It fits their experience and they evaluate the abstracts favorably. Men, they don't see it every day, don't think about the problem. It could also be a matter of defensiveness. After all, Hanley explains most men don't want to think they're bad people with biases against women. Most men, of course, aren't bad people, and they're not any more bad than most women. They're not saying that male faculty in STEM are evil or trying to put people down. Sarah Jane Leslie, a philosopher at Princeton University, says these are implicit biases and everyone has them. It doesn't make you a bad person, it makes you a human being. She says the study itself is fascinating and important. We need to acknowledge these issues so we can talk about them, she explains. If some people are less likely to acknowledge these issues, it's very detrimental. So it's okay to have biases because we are humans. The human experience is filled with sometimes contradictions. Sometimes we pay attention to one thing but not the other, and yet we should be aware of both things at the same time. And the most important thing is to talk about it and have an open discussion. But if some people are not willing to admit that there's a problem or something to be said, that in and of itself is an issue. Part of the problem, explains Erica Contrell Dawson, a social psychologist at Cornell University, is that this is one area where people use their own personal experience to decide whether research is legitimate or not. She says it's natural to read a scientific paper and check in, ask, is this how I experience the world? And if men are not experiencing the world that way, they will be a little more skeptical. Is it a biased view? Sure. It's not the way science should be done, Dawson notes, but it's the way human reasoning, or well, the human mind goes. The most surprising thing, says Ellen Peters, another psychologist who studies decision making at Ohio State, is that no one had done this study before. As humans, we're influenced by a huge number of influences and biases, she says. If these people are being biased against women, and it can be explained by very subtle, unintentional differences, that's holding back a whole world of people contributing to our society. Peters says she would like to see the study replicated with more participants, as well as to see just how much these preconceived notions might contribute to behaviors such as hiring. Smith and her colleagues have already started applying the results of their research. They designed an intervention, randomly assigned her hiring committees to a program meant to help people recognize unintentional bias and give them tactics and resources to successfully recruit more gender diverse faculty. And the intervention has already worked. Hiring committees who got the intervention were 6.3 times more likely to offer a position to a woman than committees that got no intervention. The improvements went the other way as well. When they got offers from committees that received education about combating gender bias, women were 5.8 times more likely to accept. The researchers report October 10th in Bioscience. So preconceived notions of bias do exist, but tackling the problem can result in improvement. Everyone is going to be better if we address the inequality, the implicit biases, and the more ideas we bring to the table, the better our science is going to be. And this was specifically about race or gender bias, but there are also racial biases as well. And it's important to remember that we are human and we have to outsmart ourselves sometimes because we behave in silly, illogical human ways. So we have to keep each other in check. for the best science to win out. So for part A, according to the article, which of the following may be affected by a scientist's bias? Select all the correct answers. So it's all of them. So scientific studies are based on observation and data collection. Scientists must analyze the data objectively, interpret it, and then draw conclusions. What does this mean? But as human beings, scientists have implicit biases that may affect how they interpret something, the conclusions they come up with, their acceptance of or suspicions about other researchers' work. Explain how men and women in general interpreted the results of the study on gender bias. We have a drop-down menu. According to the article, male scientists tended to regard the study less favorably than female scientists. Male scientists also consider the study to be less important. So it was a double whammy. Male scientists tended to regard the study less favorably than female scientists and also considered the study to be less important than female scientists did. It was interesting, though, that male and female researchers from non-STEM fields agreed in their acceptance of the study and its importance. So we kind of hypothesize, wonder about why that is. Perhaps with a little STEM knowledge, you are able to find reasons to not like a study. And when you know a little bit about a subject, people kind of get a little overly confident in their ability to analyze things about that subject. So humility and a little bit of skepticism is okay. The article mentions that the difference in the response of men and women to the research study could be due to confirmation bias. Use the internet to look up confirmation bias. Which of the following statements could support the view that the difference is due to confirmation bias? So we're just gonna search the web. So from Wikipedia, confirmation bias is the tendency to search for, interpret, favor, and recall information in a way that confirms, hence the name confirmation bias, or supports one's prior beliefs or values. You can also look at Simply Psychology. There we go. People are prone to believe what they want to believe. People like to be validated. So let's select all of the correct answers. So many of the women may already believe that they face biases. Many of the men may believe that they are fair and unbiased against women. So both have a subjective experience of the same reality, right? So confirmation bias is the tendency for all humans to look for and interpret information to be consistent with their current understanding of the way things work. Even scientists and researchers will start to look for other data or other interpretations if results don't conform with their expectations. In this case, women who have personally faced this bias will be more likely to accept it than men who have not had that personal experience. So personal experience can color our interpretation and analysis to some degree. And that's it for that one. And the rest of the lesson is about bias, research bias, and there are many factors we have to keep track of. and minimize as much as possible. Selection bias is a result of poor sampling techniques. And this can occur when you select and it's from a biased population, or it heavily focuses on one area. So for example, suppose that scientists want to measure the average mass of an iron atom. If they test only iron that came from a certain location, it wouldn't accurately represent the average mass all around the world. So you have to sample from random locations, and then the average will be more reliable. And it's important to note that you can't completely eliminate biases. Both the confirmation bias and the selection bias creep in unintentionally. So you have to take steps to minimize the potential for bias in a study. Oh, and here's another question. Confirmation bias based on a person's own beliefs, selection bias caused by poor sampling techniques during experimentation, and then both can be controlled but never eliminated. They're both a type of research bias. They both can affect the way a scientist interprets experimental results, and they are unintentional. And there's a little blurb about them too. We can control but not eliminate. And that's the end of the Intro to Physical Sciences. I hope that little walkthrough the lesson activity was helpful, and reading the article helped you out. And if you have any questions, message me in Canvas, and I will get back to you as soon as possible. Have a great rest of your day, and I will see you later.